Okay, so the first thing that we are going to do is discuss categorical data and quantitative. Okay, so that's vocabulary-wise what we want to learn first. So on your first page, we got categorical means things are in categories. Categorical data are in categories. So in science, you would call this qualitative because they have certain qualities, okay? And what happens is this data will end up as proportions. We'll end up taking the information and categorizing it and then making proportions out of it. So, for example, word labels, even numbers used as labels. So, if I ask you the proportion of a particular color in M&Ms, that would be categorical. Even if I asked you, hey, what proportion of Aledo High School residences have the 76008 zip code? Okay, so even though that is a number value, it's a category. So it's still a category of the particular zip code. All right, so categorical data, qualitative. Next is quantitative. So this is whenever you actually have quantities. And what we'll end up doing with those numbers, they are quantity values, so we'll end up averaging them. Okay? So we'll have things such as time or distance, okay, or a scale of 1 to 10. Okay, and we've talked about that averaging or proportions in the last unit that we had. By the way, you might start liking this unit better than before because we get into real numbers, and real numbers that mean certain things, and so if you're a more numbers person, then it's going to get better for you. All right, so ways that you can display categorical data. That's what we want to talk about next. A frequency table. You guys made a frequency table when you did your bear hunt lab. When you went outside and you tallied everybody's colors that they got, that was your bear hunt lab. So, for example, here, this was blue, red, orange. It was all the colors of the M&Ms. And you would have tallied and you got your frequency. So, frequency is the actual counts that you got. All right, but most of the time what we do with that is we will take it and look at it relative to the total. Hey, when you went on your bear hunt run outside, you all counted different numbers of bears. Would you agree with that? You all had different totals. So in order to compare those to each other, we had to count them relative to your total. So that's what relative frequency does, is it compares the counts relative to the total. And then a lot of times what we'll get from that is then we get the percent. For example, this was 13 blue M&Ms relative to the 55 that were found when you did your flyover. Of course, we didn't have the blue we didn't do the turkeys. But that is 0.236. So that's that relative frequency that you could turn into a decimal, 23.6%. Okay? So that's what you could, that's the relationship between frequency and relative frequency and your percent relative to the total. Okay. Now, down below we have two charts and they show two different kinds of things. What kind of data does this chart on the left show you? Frequencies, relative frequencies, or what? Good. These are actual counts. So it is showing you frequencies. Okay? And this one on the right is showing you what? Percentages. So these are then relative to their total. So these were the relative frequencies. Okay. So that's the difference between just plain frequency and relative frequency. Okay, moving on. Now, In this section here, we have another way to display data. Based on this data, this is a segmented bar chart. So we have data that is stacked on top of each other. It is also frequently called a stacked bar chart. Okay, so those are two phrases that mean this kind of picture. Is this one a stacked frequency chart or a stacked relative frequency chart? Yes, just regular frequencies. Because if it was relative frequency, they would all top off at 100%. You would top off each quarter and you would show the total 100% of data within each quarter, and you'd have different lines and stuff. Okay, so this is definitely just plain frequency. Okay, moving on. Now, the next thing that we need to make sure that we address is to not violate this thing called the area principle. Area principle means that your picture does not accurately reflect the proportions of the data. So this means that your areas are misleading. They can draw you to an incorrect conclusion because they are not proportionate to what they are supposed to represent. You know, they are not proportionate to the amount, to the actual amount. They are not proportionate to the actual amount. All right, so we're going to take a look here. This information in these two graphs represent the deaths on the Titanic. Okay? And I'm going to tell you that the class that you were in, the ticket you had, first, second, third, or if you were on the crew, affected the rate at which you died or survived on the Titanic. Okay? So let's take a look at this picture on the left. Of those four values on the left, which one looks like it had the least deaths? Okay, good. So this appears, it appears to have the least deaths. And which one appears to have the most deaths? Third. So this appears to have the most deaths. Okay? Now, that's all nice and pretty and all three-dimensional and everything, and it looks nice, but look over here at the actual values. If you look at these actual values, which one had the least amount of deaths? Second class had the actual least. And which one had the most? It's hard to see. Third had 700 and something. Crew had 800 and something. So crew had the actual most. So would you say that this beautiful three-dimensional drawing was misleading?
Yes.
Yes, it violated the area principle. Okay, so let's say three things that's wrong with this graph at the very bottom. It is about marijuana use, heavy drinking, and alcohol use. So what's one thing? Yes, ma'am.
I just have a question about the graphs.
Okay. Question back on the graphs. Go.
On what circumstance, how would you mess up the graph like that? Like what causes it to be different?
So, and you know what? I'm going to show y'all some of these tomorrow. I didn't have them handy this morning. Like news people, they will want to have a pretty graph and they'll show it, and it will be a misleading graph. I'll show you actual real things that people have put on the news that is an incorrect graph with misleading results. They just are not thinking, you know, or they just let it skim. They just skim past it. You know, somebody probably didn't notice that whenever it made this picture right here, that it threw off the results and didn't show it. So, yeah, you'll be when I show you the ones tomorrow. You're gonna laugh at it. It's hilarious. Okay, but let's take a look at this down here. Explain what's wrong with this graph below. Yes. See this 50%? 50%. Does it look like half? No, 50% does not look like half. Okay, that's one problem. What else? Yes?
Heavy drinking would be a subset of alcohol.
Okay, good. This heavy drinking and, is a subset of alcohol use. So these 31.5% should be in that alcohol, and so you're going to have some double counting going on there. All right, and then another one I thought I heard.
It doesn't add up to 100.
Yep, it does not add up to 100%. I know, gosh. Okay, so I'm just thinking of some of the ones that I want to show you tomorrow. You're going to love it, okay? We'll have some fun tomorrow thinking about that. Okay, but we're going to get on to the rest of the stuff. Here we go. And it happens in real, oh my gosh, you're just going to have to watch the news or watch the commercials or whatever, and I'm telling you, they are messed up sometimes. Okay, here we go. So now, the 3 things that I'm going to teach you next are about marginal distributions, okay, conditional distributions, and one final vocabulary word we're going to talk about today, independence. We will talk about independence a lot this year. Okay, so first things first, marginal. Marginal distributions, let me ask you, in your English class, where do you have the margins? On the edges, on the outside. This here is a marginal set of data. This here is a marginal set of data. So the margins is on the side, the edge. It is the totals. It'll give you information about overall what's happening. See, we would be able to, so let's kind of talk about this problem. This is about, we had 3,000 people, we have their genders, and then we wonder what Super Bowl activity they do. So do they watch the game, do they watch for the commercials, or do they not watch at all? And so these marginal responses would tell us this, total amount that watch for the game, total amount that watch for the commercials, and so on. Or it would tell us the proportion of males in our sample, the proportion of females in our sample. That's what the margin would do overall. Okay, so let's actually do some of these. So my first question before we start calculating some numbers is, what variable, so let's talk about the 2 variables we have here. One of the variables is gender, and one of the variables is the Super Bowl activity of choice. Okay, so which variable is explaining the other? Which one drives or affects the other one?
Gender affects the...
Perfect. Gender is we are going to speculate, or we're going to see if gender is affecting what you watch. So we will end up doing our fractions. When you figure that out, that will help you know which way to do your fractions. Okay, so we're going to do our fractions in this direction. So if I was to do the marginal, then that's going to come over here from the right, this information here. So overall, what proportion are watching the football game? And we'll be doing, we'll write the fractions out all the time, in this unit at least, because it's kind of like showing your work. So if you make a mistake, then I can see what you did wrong to get the wrong answer. And that is 40%. What proportion watch commercials for the commercials?
1,000 over 3,000.
Okay, and so that's 33.33%. And what proportion will not watch it at all? 800 out of 3,000, which is 26 and 2/3%, because that's a total of all of the people and that they did any of those 3 things. Okay, we're not going to draw the picture on that. Okay, now, conditional. Conditional, if I say something is conditional upon something else, what does that mean?
It depends on it.
It's related to that other thing happening. It depend. Okay, we want to say it depends on it happening. Okay, and we'll talk about that word depends on here in a little bit. So if I say conditional upon you being a male, I want to know at what rate do you do all the things. Then I'm talking about this little section here in the middle. Okay, so the conditional responses are in the center where it's kind of like the subsets. It's conditional upon you being a male, conditional upon you being a female, and so on. So that means if I'm going to write out this conditional upon you being something else, so that's what I want to put here, conditional, I'll do that here, conditional upon you being something else, or having a particular trait. Conditional upon you having a particular trait. What's the rate at which something happens? So, our conditional sets of data will be conditional upon you being a male. I want to know the rate at which you watch the game, watch for the commercials, and won't watch at all. See? And then I want to know conditional upon you being a female, at what rate do you watch the game, watch the commercials, or you won't watch at all. So see, I have two sets of fractions here, not just one. The first one was the overall rates. These are now going to be the two subsets. Okay? The first one was the overall rates. This one will be the two subsets. Okay, so let's come up with some numbers there. Conditional upon you being a male. How many males were in our sample, by the way?
1,800.
Yeah, conditional upon you being one of the 1,800 males, so I know all my denominators will be 1,800. What is the probability you watched what proportion watched for the game? What was the number there?
720.
720. What's my number for commercials? And then for won't watch? For what?
480.
Okay, so guess what those percentages all come out to be? Like magic. 40%, 33 1/3%, and 26 2/3%. Okay, so do you see where those numbers came from? They were these here, these fractions out of the males. So we're going to now do the same thing for the females. Conditional upon you being a female, here are the rates at which you watched did the Super Bowl things. So those were, was it 480 out of the 1,200 females, 400 out of the 1,200 females, and 320 out of the 1,200 females, which, amazingly enough, dun, 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 isn't data nice when you can just plan it? Okay, you know this doesn't ever happen, that it comes out so beautifully perfect like that. But look at what just happened. Can you tell me what happened with the male and the female data compared to the overall? They are all the same. So would you say the fact that you are a male or a female is what? Irrelevant. It is not changing the rate at which you do your Super Bowl activity. In fact, let's write that down specifically. The fact that you are a male or a female does not change the rate at which you do a particular Super Bowl activity. The fact that you are male or female does not change the rate at which you do a particular Super Bowl activity. And so that's important. That's one of the major things that we want to talk about to see if, ultimately, I want to know, are Super Bowl activity and gender independent variables? They are independent variables if the fact that you are one thing does not change the rate. In fact, I have a little song of that we're going to use all year long. I mean, we will visit independence throughout this whole entire year. And the cool thing is that this little ditty, this little song that I'm going to sing you, is consistent throughout all of the times we address independence. Okay, so it goes to, oh my darling. Oh my darling, but it's independent, independent, independent. When the fact that you are one thing does not change the rate. In fact, if you look at the front of your packet, your words are there. And so we'll take a look at it here. Should be the very first, it's right here. Independent, independent, independent. When the fact that you are one thing does not change the rate. Okay, so that's what's important there. Of course, there is a video for it. Okay, now we are not in experimental design anymore, so if you go to Mary Mac on YouTube, we are not in the experimental design playlist. We are in descriptive data playlist. So let's take a look at that. Okay, so I don't have internet connection, so we'll watch the video if we can at the end. But so the question is, are the things independent? So according to our song, independent, 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 when the fact that you are one thing does not change the rate. So what do we have to say? Gender. Okay, there I'm going to write 3 phrases. One phrase. Gender and Super Bowl activity are.
We can't see anything.
Oh, you can't see anything?
Are we not doing the graph?
We already did it.
Oh.
So gender and Super Bowl activity are. So I'm trying to write. Okay, let's try that. Gender and Super Bowl activity are independent. Okay, that's one phrase. Gender and Super Bowl activity are independent. Okay, the second thing that we can say about this is gender affects Super Bowl activity. Is that a true statement? Yeah. Gender and Super Bowl activity are independent of each other. Oh, wrong. Sorry, that's not a true statement. Thank you. I'm just seeing if y'all are thinking or not. See? Just got to see. Okay. Gender does not affect Super Bowl activity. Okay, cool. And then I can say this. Gender and Super Bowl activity are not related. Okay, so let's think about those 3 statements and see if you think they all mean the same thing. Gender and Super Bowl activity, they are independent of each other because they are not affecting each other and they are not related to each other. Okay, so they're not related. Okay, good. The final thing we want to do is make a picture of these events and see what does the picture look like if they are independent. So we're going to take our data and we're going to make a graph for male and a graph for female. We are going to make a stacked bar graph and we're going to make it relative frequency, so it's going to be out of 100%. So this is the percent that chose a particular activity. Okay, so here we go. We're going to have 100% of the females choosing activities and 100% of the males choosing activities.
Should there be 3 bars for each?
So I'm going to now segment it out. Okay, so let's go ahead and say the watching the football game are stripes, and watching for commercials are squiggles, and won't watch are polka dots. Okay, so now we're going to segment this out, okay? So what is our percent for won't? Let's do the bottom part. What's won't watch? How much is that? Okay, 26 and 2/3. So draw your little line up here to 26 and 2/3, and that's your polka dots. How much is it for females? Okay, it's the same. So it will look the same. 26 and 2/3. Okay. Yes.
Does it matter what order you do the bars in?
No, it does not matter what order you do the bars in. I'm just kind of going to do them the way that our data is. Now, on top of that will be the commercials. How much is the commercials? That's 33 1/3. So we're going to add that on top of the won't watch. If I add 33 1/3 to that already existing, you know what that brings me up to? 60. Okay, so that's going to take me up to 60. And males and females are the same. And so that's the squiggles. And then the top is 40%. And that's the stripes. So this is a stacked bar graph. It's a segmented bar graph. And if the data is independent, then what can you say about the drawings? They will not affect each other. They will look the same because the fact that you are one thing is not changing the rate. So the percentages are the same. Okay, done with that. Moving on to one that does affect it. That shows that it is affecting. So let's see. All right, same situation, different numbers. So let's put some of those numbers in just super duper fast. You ready? Okay, where would I get my marginal numbers from? Over here. Now, which way do the arrows go? Which is the explanatory? Good. Males and females are driving it. So this is going to be the marginal here. And this will be my conditional section. Okay, so let's go ahead and plug in some numbers there. You can start doing that. And I'll fill in some numbers too so we can get that real fast. So there's our numbers for the marginal. So you can see overall the proportion of the population, if this is representative, that watched for the game, watched for commercials, or don't watch at all. Okay, now we want to see if the subgroups, males and females, will do that at the same rate. So where does that data come from? Under this conditional. So we're going to make a set of fractions for the males and a set of fractions for the females. So let's do that. Okay, so this is our conditional numbers. I just stuck those in there. Those are the conditional numbers by gender. So looking at that, what do you think that we can say? The fact that you're a male or female is changing the rate. So let's say let's write down the three phrases we can say. Gender affects your Super Bowl activity choice. Okay? We can say, what's another thing we can say? Gender, or actually it'd probably be better to say Super Bowl choice is related to. That'd probably make more sense. Super Bowl choice is related to gender. To gender. Now,
Any of these three when we're explaining it or whatever?
Yes. Okay. Now, listen up. This is important. You cannot say the Super Bowl choice depends on your gender, and here's why. If I say something depends on something else, mathematically, that implies a direct correlation. Like, that means like a function, like y equals 2x plus 3. That implies, if I say depends on, that means something like this. You could make a graph, and you would have this function, y equals 2x plus 3. And if I told you an x value, you'd be able to compute the y value. That means y depends on x. Y depends on x. That's a direct relationship. But is real data perfectly correlated like that? Real data is like this. It's scatter plotted. Real data, which is what we're all about in this class, is not a perfect correlation. So never say depends on. So what do we say instead? We say gender is not independent. That's our special phrase there, is not independent of. I should probably say the other way around. I think that would make more sense. To say that your Super Bowl choice is not independent of gender. It's connected in some way. Okay, it is not independent of gender. They are connected. All right, what do you think the picture's going to look like?
It's gonna be like one of the two big.
Yep, they're going to look different. So let me
It's more like the Twin Towers.
So let me put that in there for a second. So there are what the two side-by-side stacked bars would look like. And do you see how they're different from each other? That's implying that the fact that you are one thing is changing the rate. If it's changing, that's not independent. Okay, so in summary, we've figured out, we know what conditional values are, conditional distribution, marginal, and we know how to connect if things are independent or not, and what the pictures look like. Okay, so let's take a look at this set of pictures right here real fast. Okay, so here, number one, would those two things be independent? Take a look at those guys right there. Are they independent, or does the fact that you're one thing look like it's changing the rate? It's changing, so that means not independent. Okay, good. Number two, looky here. There's 40% of females in the sample and 60% of males in the sample, or whatever. So consistently, of the games, it's consistently 40% for females and 60% for males. So the fact that you are, oh wait, is it? Hold on. 60% of the things, the fact that you are one thing is not changing the rate. So that, what does that mean? Independent. So it is independent. Okay? Number three, what do you have to say about that? Yes, it is independent. Number four?
Independent or not? Or
It is not independent. Good. Number five?
independent.
Yes, it is independent. Number six? Not independent. Good. Moving on. Your homework is going to be pages 5C to page 7. And so we're going to do a little bit investigating here to demonstrate some stuff. Okay? So we've already done this type of question right here. Hey, sit down. We still got 8 minutes. We're good. Okay? So let's actually talk about this here. The directions. List the conditional and the marginal, and then tell me if it's independent or not. Okay, so look at this. First problem. We have type of driver, student or staff. And then we have origin of the car, where it came from. And this is type of driver. Which one is influencing the other? Which is affecting the other? The student staff is doing what? The fact that you're a student or staff is affecting, or we're going to see if it affects. Okay, so which way do my arrows go?
Top to bottom.
Top to bottom. Good. So I want to show you how you got to organize this. So that means conditional. You're going to have to squish in your stuff. Conditional upon you being a student or a staff member. And then this would be your marginal data. So here is how what you're going to do for me looks like. You're going to have your little lines. We got American. And we got European. And we got other. And so now we're going to collect our data, and I'm just going to give you a few sample fractions. What would be this top left fraction? Upon you being a student, what's the probability you have an American car? What's this fraction up here in this top left corner? Good. 107 American cars out of the 195 students. Okay. How about this one in the middle with staff? What's the American staff? 105 staff members have an American car. Conditional upon you being a staff member means the denominator is 164 is the denominator. So overall, what rate do people have American cars? 212 out of 359. And then you would figure out that in percents so you could see if that's independent or not independent. Yes?
If the first set of data is not...
I do want you to figure them all out because tomorrow we're going to talk more in depth about the numbers, okay? So do figure out all the percentages because we're going to talk about them in depth tomorrow. All right. Last thing, look here. Do you think we got blood pressure and we got age? Which one affects the other?
Age affects blood
Good.
pressure.
Age over here on the left is affecting blood pressure. So which way are my arrows going to go?
Bottom.
Left to right.
Same thing.
Left to right. So let me show you how that will look. That means conditional upon you being under 30 or 30 to 49 or over 50. I don't know what happened to the 50-year-olds, but anyway. So then, yeah. So let's look at how our fractions go. Because then we have marginal will be this last one here. All right. So what is my first top fraction? Conditional upon you being under 30, what proportion have low blood pressure? 27 out of 95 or 98? 98 because it's conditional upon you being under 30. So conditional upon you being under 30 means all of the denominators on these is 98. Okay? Let's do this one right here, this second square here. Conditional upon you being in the 30 to 49 category, what's the probability you have low blood pressure?
37 out of 179.
37 out of 179. Good. These are your denominators over here on the right. And so on. And then you tell if they are independent or not. But do fill out all the numbers because we're going to talk more about them tomorrow. Have one last thing to go over with you, and is on page 6. So you do page 5. Okay? And then page 6. The second problem on page 6 is this one here. It's about your ethnicity and your admittance decision. If you were accepted, waitlisted, or turned away. Which one do you think drives the other?
Race drives acceptance.
Ethnicity probably drives the admittance. Now, I want you to, on these, pay close attention to the denominators, and we're going to do that here in a minute. Denominators, exclamation point, and here's what I mean. Look at this first problem. What percent of all applicants are Asian? So what's the denominator? Total applicants, which is how much? 1755. Okay, and so you got it, the general gist, and you can keep looking at those. I'll put the answer on the rest of the video if you feel you need to look at that for checking yourself. Okay, so then of the applicants, of all the applicants, the portion that are Asian is that 292. Okay, B, what percent of the students accepted, so that's your denominator. So, of the students accepted, so that's 931 is your denominator. What of the students accepted are Asian, and so that's 110. And so then next, what percent of the Asians? So that makes our set that we're looking at going across this way. So our denominator is going to be this 292. So of the 292 Asians, what percent were accepted? Is that 110? And then we'll check that last one. What percent of all students? So we're again doing all students in the proportion of those that are accepted out of the total. Okay? And so then that is how you would come up with that fraction. All right. So in summary, your homework is pages 5C through page 7.